The next topic we're going to discuss in simple linear regression is, now that we have the best possible estimate for b sub 0 and b sub 1, now how good is this best possible estimate? The best possible estimate doesn't mean it is great. It is the best possible estimate for the given data. So we want to now figure out how good is this best possible estimate. And for that, we look at the total variation that is present in y. So that's given by SST, total sum of squares. That's given by taking each y value, subtracting y bar and squaring that. Okay, so that is here we are not including x in any way. So this is the inherent variation that is present in the values of y. Okay. Now we separate that into two parts. One is, of these variation, the amount that is now explained by the regression line. So that is given by SSR. So the difference between y bar and y hat, the square of that, that's your SSR, and what remains, the balance, is your SSE. So we can illustrate this with a graph. So let's look at a graph now. Now here is x in x-axis, y in y-axis. Now suppose if you ignore the x's, then if this is y bar, then each y value will differ from y bar by some amount. So you take that difference in for each point, square that and sum, that's your SST, where we are not including x in any way for predicting y. But once you include the prediction of y using x using the regression line, so now y bar becomes your estimate. Okay. So the difference between that the y hat becomes the estimate. Y hat is our, so once you introduce the regression line is your estimate, not y bar. Y hat is what your estimate for y is going to be. So the error now is y minus y hat. Now that part which was error previously is now explained by the regression. So y hat, that point is y hat minus y bar is the amount of error that is no longer present. So that's the error that is explained by regression. So take that error, square it for all the points and add them up. So that's your sum of squares due to regression, sum of squares that has been explained by regression. The balance is your SSE, okay, y minus y hat, square that and sum that, and that is SSE. Now if the regression is good, then most of the error, total sum of squares, will be explained by SSR and very little will be left as error. If the regression is not very good, then much of the error will be left over. So we can compute a ratio between SSR and SST, which is called coefficient of determination. That will tell us the proportion of total variability that is explained by the regression. Okay, that's given by this formula. So here both are sum of squares, so this will always be a positive number. That's why it's called R squared, and the R squared value is between 0 and 1 if all of the variability is explained by the regression, which means the lines, the points fall exactly on the regression line. So there is no error at all once you introduce the line. So SSR will be equal to SST. That's the perfect situation. So if the regression is perfect, R squared will be equal to 1. If the values are all over the place, then R squared will be closer to 0. So here is a way to understand R squared values. So if you have a regression equation like this, R squared is going to be equal to 1 because all the sample points fall exactly on the straight line. Same here. But if you have situations something like this, okay, it doesn't matter whether it is negatively sloped or positively sloped, R squared will be closer to 0 here. And here it will be even more closer to 0 because as you see the variance in y is greater for this example compared to that one. Now you may wonder what is the relationship between r squared and the coefficient of correlation we talked about? And that is, if you square the correlation coefficient, you will get coefficient of determination. So of course, the coefficient of correlation can be positive or negative. Once you square it, it becomes a positive value between 0 and 1. So if you want to go back to correlation coefficient from coefficient of determination, then you have to take a square root of r squared, and then you use the sign minus or plus based on the slope. Okay, if b sub 1 is negative, then you use the negative square root of r squared. If the slope coefficient b sub 1 is positive, then you use the positive square root. So let's compute this for our Excel example now.